Okay, 5, 4, 3, 2, 1. We are putting chapters 7 and 8 both together here. Chapter 7 is very, very short. I don't think it should be a problem for us. We'll see. Tomorrow, our friend from Riverland is coming back. She has to visit twice during my first time teaching the course. And so she'll be here. She'll be sitting right back there. And you can say hi if you want to. Today we begin with parameters and statistics. First example, a random sample of 580 registered voters were selected at random and asked about if they approve of the job of the president. On Gallup, the presidential polling for job satisfaction is one of the most important and useful pieces that they track all the time. It says 275 indicated that they approved of the president's job performance. Okay, so the population. When we identify population, the population is the entire group about which we want information. Okay. So when this question is asked, generally speaking, we want to know from, say, all adults across the entire United States, that's our population, what is their opinion of the job performance of the President of the United States? Okay? Something that gets tracked at least a couple times a week. Within that, we have a sample. Sample is the part of the population that we collect information from. That looks like something you've seen before. It's because you have. Okay? We've talked about population and sample before. But next to it, we're going to put parameter and statistic. And so a parameter is a number that describes the entire population. For example, it might be the case if you ask every single adult in the United States, it might be the case that 47% of people approve of the job of the President of the United States. Do you think 47% is high, or do you think it's low? It's actually high. Doesn't really matter who's in office right now. Most presidents are getting job approval ratings usually between about 38% and 45%. Okay, the view of politicians overall has been negative for about the past 15 years, largely due to the way we get our news through cable stations as well as TikTok. That seems to be how we get our news. Okay, and we all know that we're more likely to click if we see something negative. Everybody agree? So job approval ratings are definitely on the lower side. Very uncommon right now for a president to have a job approval rating above 50%. What's interesting about this parameter is this. It is usually unknown. The reason why it's unknown is we can't really, sample the entire population of the United States. That would be really, really, really difficult. And so this parameter is something that we talk about in this situation. What percent of people approve of the job performance of the president? That's what we like to know. And so since we can't come up with the parameter, we come up with the statistic. The statistic is a number that describes a characteristic of the sample. We use the statistic to estimate the parameter. Nobody in statistics ever thinks that the statistic they produce is 100% accurate in estimating the parameter. We always know we're off by a little bit. The key is to be able to communicate to the people, how close are we? So if we say that the job approval rating of the president is, say, 44%, how close are we to that? You know, with what confidence can we say that? So that you guys can make a decision for yourself whether or not you trust that piece. Some very interesting things came out in the news yesterday. Did anybody hear about the hormones that sometimes women use later on in life? That there are warning labels on that they could lead to higher levels of cancer and stuff like that. That has now been debunked. We've learned a lot within there was like a $4 billion study done within the medical community about these hormones that women may receive or may not receive around the time of menopause, and people were cautioned. It turns out that we were wrong. And a lot of statistics went into that, and we learned what we did right, what we did wrong. And we want to be able to have confidence about some of those things. So, going back to the first example, we want to identify the population, the sample, the parameter, and the statistic for above. Okay? I'll read it again, and then we'll identify that. A random sample of 580 registered voters were selected at random and asked if they approved of the job of the president. 275 indicated they approved of the president's job performance. Talk to the person next to you. What do you think is the whole population in which we are trying to learn about? Go. The population is all registered voters. What is the sample? The sample would be 580 chosen at random. We like the random sampling, don't we? Random sampling is a very good idea. The parameter is the number that we probably don't know, but is going to describe the entire population. In this case, the parameter is the percent of voters who approve of the president's job performance. We would really like to know that number. That'll be good for the White House to find out. That's going to change the way that they talk about legislation, the way in which they run races, who they're going to try to back for certain races and who they're not. Take out your calculator.
I was like, I saw it. I did a good job because I knew you. Because I didn't see you on that one.
Okay. We go ahead and we take that 275 and we divide it by 580. Confirm that you get 47.4% approved. Of the president's job performance. Now, what's interesting here is that I don't think anybody here believes that 47.4% is 100% accurate to estimating the parameter. That the actual number of people who approve of the president's job performance, it might be higher, it might be lower. But by how much? And one of the ways in which we can refine this study, which we'll look at later, is we could increase our sample size. In this case, we have 580 voters. Suppose that we surveyed 5,000. We could definitely be more confident in that situation, and that might be something that people would try to do. And we'll talk about that more as we go.
Jens, I got a question.
Sir.
If you're doing that survey, how would you do it though, like with the location that you're doing it at, and like, because obviously like where you survey can sway it.
So when we clicked on Gallup right here, you can actually click on the study itself all the way at the bottom, and they will show you how they got all this information. They disclose it to everybody. You can, let's see here, survey methods right here. As I click on it, They tell us that in this situation, they sampled 1,009 adults, 18 and older, living in all 50 states and the District of Columbia. So they did all that. They have a margin of error of plus or minus 4% is what they do in that situation for this one. They said that 80% of people they called were on cell phones and 20% of people were on landlines. And so they try to communicate with people that way. Some people are setting up new ways of surveying by going through social media and other options as well. So there are ways in which they try to do it. But it's a challenge. Trying to survey people is hard. It isn't easy. Okay, so let's go back to this piece. I want you to look at example number 2. It says 5 boys were selected at random from the boys basketball team. Of the 5 chosen at random, the heights differed by 10 inches. Identify the population, the sample, the parameter, and statistic. Try that one on your own. Go.
Where are you going with that? Join the band. Bro, she doesn't just give me the car. You would be surprised. Yeah, you let it happen, but
So we took the sample from the boys basketball team. The population is the entire boys basketball team. It might have 10 people on it, might have 15 people on it, I don't really know. But the sample is of 5 chosen at random. The parameter, look at what we are looking at. It says the heights differed by 10 inches. That means that we're looking at the top height and the bottom height. Anybody know what we call that measure of the data if we're looking at the top and the bottom? The max to the min? It starts with an R. The range of heights. Range of heights of the basketball team is what we're trying to discover. Now, in this situation, probably won't be that difficult to get them all together and measure, but just trying to show you an example. The statistic is the range of heights is 10 inches. Now, we haven't talked about a variable for range, but could everybody say that we could use R as a variable for range? So we would say that this has a variable of R. For a statistic, we don't use R, we use this, R hat. So if you see a hat on top of it, that means that it's a statistic. It's not actually the population, it's the statistic. Sometimes there's parts of the population that we know to be true. For example, sometimes we know the standard deviation to be true. Look at the next one. Recent snowfall left a large amount of snow in Joshua's yard. He measured 8 locations in his yard with a yardstick. The maximum depth was 19 inches. Identify the population, sample, parameter, and statistic. Try that one. Go.
let me do this problem.
I guess the parameter would be the depth. The parameter is going to be a number. The population isn't necessarily a number. The population is just the thing in which you're collecting a sample from. And those are just all the locations in Josh's yard. We chose 8 of them at random. I guess it doesn't say that he necessarily chose them at random, but he chose them. And so the statistic in this situation, it says that he measured a maximum depth. So we would say that the statistic is max hat, so the maximum was equal to 19 inches. Try one more. This is very similar to a problem that you would see within a real life situation. 2,300 adults were randomly chosen and asked their yearly income. The average income of adults was $82,400. Identify the population, the sample, the parameter, and statistic. If it doesn't tell you that it's from a certain state, if it doesn't tell you it's from a certain town, we can assume in this situation that the population is all adults of the United States.
It's not. Cheers.
So remember when you write average, you can write mu with a hat on it. Okay, the last part I want to go today is talking about our instruments of statistics and how we try to gather this information. So Sam was right in that he said, well, how do we gather this information? And cell phones may not sound like a great idea, or landlines may not sound like a great idea. Social media might not sound like a great idea, but we struggled to come up with people's data. If somebody called you and wanted you to do a survey, would you take the call or would you hang up?
Probably hang up.
Yeah, most people would hang up, which is really a problem. So if you do get a call and there's some statistics involved to it, go ahead and respond to it so you can give them an opportunity. So the first question is the instrument that we're using valid? Meaning, is it a reasonable way Okay, so is calling somebody on the phone and asking them their opinion of the job performance of the president, is that reasonable way to gather information? Absolutely, right? Is there a better way? Maybe, but it's reasonable to say we're going to call somebody and ask, okay? We have to consider bias. Bias, what it does is it is more likely to produce one result over another. If we only called on cell phones, then it would be biased because we're not getting a population that doesn't have cell phones. Who would be the population that wouldn't have cell phones? Amish, older people, okay, definitely have some opportunities there. So we try both. If we only did social media, well, you're missing out on me because I don't have any social media, okay? Reliable.
That's literally talking.
If an instrument is reliable, it will produce consistent results every time. It may not be, it might be biased, but at least it produces something that's consistent. You can trust that it's going to give you a similar result over and over and over. This is important because it reduces variability. So when you're trying to come up with a sample, you can kind of think of having some error by looking at these targets. And here's the target that you can get. Suppose you end up with a target like this. Okay? Suppose you're shooting an arrow or a gun every time and you're hitting that part of the target. Are you getting consistent results?
Yes.
Yes. So that means reliability is good. Are you more likely to hit one part of the target in a situation? Yeah. So that means the bias is bad. You are more likely to be skewed towards one region. That makes us not very good. You might have some shots that look like this. Tell the person next to you, what do you think about bias and reliability in that situation? Go. What do you got? Bias and reliability in that situation.
Not very reliable.
Okay, this is no bias, but there's no reliability here. We're all over the target all the time. You could end up with a situation like this. This would be like J.J. McCarthy throwing a pass. What do you think about that? Is it bias?
Yeah.
Yeah. The bias is pretty bad in that situation because you're only headed off towards that one corner. Is the reliability good? Are you hitting the same spot every time?
No. No.
Not reliable either. How about that last one? You like that one? Sure. Yeah, that's Sam Darnold. Okay?
Jackson Dart. That might be J.D. McCarthy.
So that bias is good. Okay, there's no bias. Okay, you're hitting a variety of spots, and the reliability is excellent too. Okay, and that's really what we want.
That's Sam Darnold. I'm the same.
So what does that look like in example number 1 here? Okay, Zach is keeping track of his weight over the course of 5 days. Okay, anybody check their weight in the morning? Nobody? Okay. Thought maybe a wrestler would. We don't have any wrestlers in here, do we? Zach is keeping track of his weight over 5 days. Scale reads 176, 173, 174, 175, and 177 on those 5 days. Okay? After the 5th day, Zach takes a 25-pound weight and places it on the scale, and he wonders what that 25-pound weight is going to be. And it turns out that it's only registering to be 20 pounds. Okay? So, a lot of people mix this up, and we're going to try to sort through this to make sense of it. But, what was the instrument used to measure his weight? A scale. Is using a scale a valid way to measure weight?
Yes.
Yes. Don't confuse that with, is it accurate? We know that there's some inaccuracies here, right? But it is valid to use a scale. That's a legitimate thing to do, okay? Is his method reliable? Is he producing consistent results?
Yeah.
Yeah. I mean, my weight, I weighed myself every day of high school, and my weight would fluctuate 8 pounds within a day before basketball practice and after basketball practice. I'd sweat out a good 7 pounds, no problem. Yep, basketball practice was about running. We didn't touch the ball for 2 weeks, okay? Is his method biased? Is he more likely to produce results that are above his actual weight or below his actual weight? Below. Because if you look here, it only weighs 20 pounds. He probably weighs a little bit more, doesn't he? It is bias to produce lower weights. Hey, Zeke, if you're looking to bulk up, good news. You probably weigh more than you think. If you're looking to cut weight for pole vault, tough luck for you. You probably weigh more than what you hope you did. Flip it over. Jack takes a standardized test 3 times in order to qualify for admission to his favorite school. His scores out of 100 are 82, 57, and 99. What instrument was used? A test, particularly a standardized test. A standardized test means that we score on a normal curve. It's like the ACT or an SAT. Is using a test a valid way of measuring intelligence? I think it's reasonable. Is his method reliable? Is he producing consistent results? No. Is there anything to indicate that the test is going to produce results that are too high or too low? It doesn't say it. So is the method biased? I would say no. Number 3, a first grade student wants to record the daily temperature. So each day she looks outside her bedroom window at how bright the sun is and writes down the temperature. What instrument did she use to tell the temperature? Her eyes. Look at the sun, right? Is that a valid way to measure temperature? No. How?
She's smart.
Do you think it's reliable? Do you think, and when I say reliable, do you think she could produce results that were consistent? I don't think so either. If it's not valid, then these might kind of, go one way or another. Is it bias? It probably is bias. Two more. Stacy's doing a report for a local newspaper. She wants to determine how the community feels about the job the new superintendent is doing. She does a sample survey by asking 20 teachers in the local elementary school to fill out a questionnaire with 3 questions. The results indicate that the new superintendent is not liked due to his cutting of teachers' salaries. Go ahead and fill out these 4 on your own. See if you can get them. The instrument used was a questionnaire. Is doing a questionnaire a good way to figure out people's opinions? Yeah, I like it. Now, we didn't get to see the questions that she asked. We could maybe critique those a little bit more, but doing a questionnaire, that sounds reasonable. Is her method reliable? Reliable really means, don't think about, could she get differing opinions? Well, of course she could. What we want to know is, if she would do that consistently day after day, would she get similar results? And I think she would, you know what I mean? Suppose that she was only to ask during one time of the year or something like that, that might be a problem. But yes, I would say that it's a reliable method. You know, she could produce those same results again. Is her method biased? Why?
She's only asking teachers.
She's only asking the teachers, and it sounds like the teachers got their salaries cut, right? Yeah. So this is definitely biased. If she wants to know how people feel, she needs to ask more than just the teachers. That's silly on her part. Finally, John is gathering public opinion about the need to build a new library for the community. John and 3 coworkers personally interviewed 100 people over the course of 2 months. People who are interviewed are from different parts of the town and are allowed to be interviewed at a time that's convenient for them. John's coworkers compare the results at the end of the interviews and conclude that 68% of the people in the town are in favor of building a new library. What was the instrument? Interview. Is an interview a good way to figure out people's opinions? Yes, it is. Is it reliable? Do you think he could produce consistent results day after day? In fact, he even did it over the course of 2 months. So it's not like people just felt one time or one way one time and one way the other. He checked all those times. So yes, it is reliable. Do you think it's biased? Do you think that the group that he surveyed are more likely to lean one way or the other? No. What do you think is one thing that he could do to improve his survey? I think you could ask a few more people. Okay? I'm going to hand out to you your assignment, and I'll hand back your tests. Assignment number 1, here you go.
I don't.
I did? I just missed you?
Yeah, I'm writing a certain drawing.
Oh, no, this is my child. My name that's not your dad. My name is Noel. That's not us. So. And Nick.
If you have not taken the test, please exit stage left.
No, I gotta go.
Theo, have you taken the test? Okay, exit. Theo.
Kind of cheat.
As you guys have your assignment, I just want to mention for this unit, again, I give you guys a lot of autonomy. If you guys would like to do your assignment the day of, or if you'd like to put it off way to the end, you guys really need to choose what you're going to do. But don't make your procrastinating interfere with my life, okay? So I'm very, very, very busy right now, not going to lie. So if you put things off, don't come to me with panic button, okay? That's your problem, not mine. I hope you figure things out, but if you choose to procrastinate, live the life you choose to live. Here we go, in no particular order. Nice job, test went very well. I don't have a box of Whisker plot for you. If you want a retest, you get 1 retest a semester.
What is that?
So 49, or 41, excuse me.
You're gonna have a hard time.
Where'd you get there? This is the one team that did I don't know. You left it like.
You're gonna have a hard time.
Well, I can go. I got a bunch of rest. Oh,
Yeah.
wait, what? I just got it. Got it. Wait, we got it. Oh, me too.
You lay with that on your computer.
Oh. I need to do a.
We're only funds were.
I've never seen some of those. I half a polio.
Mediation instead of
I've never. Oh, yeah, half. Looks like one.
Right? This part, I see.
Oh, man. Oh, I didn't.
Oh, yeah, I didn't even write that. There's no tip that I got that.
The test went well. The question that baffled me was problem number 2. So, the number of spaces moved, you can either move 0 spaces, 2, 4, or 6. A lot of people didn't have the 0 there. And then because half the time you roll the die, you would move 0 spaces, that probably would be 0.5 for 0. And after that would be 1/6 or 0.16 each time. So, the rest of it went pretty well. That was that's the one that people struggled with. The rest of it was good.
Dude, I didn't remember. No, I remember looking at them.
Agree tempted to just write 2. Okay, so back for you. Good job. Again, if you like to test, please come and see me.
It's only the front page.
It's in the grade book, hopefully today. Hopefully today.
Yeah.
So Ben, I have a question for you. Yeah. I've heard that people are putting prop bets on baseball about who's going to throw a strike or a ball the first inning of the game.
I did hear about that.
And that now pitchers are intentionally throwing the ball in the dirt.
That's fellas for.
Well, should we really be allowing these prop bets to happen? It looks like it's infiltrating baseball and basketball. And it's kind of nasty. Like, why watch the game if now it's rigged? If players are caving to this stuff, that's pretty bad. Yeah,
I'm gonna be gone next week.
we'll miss you.
I'm going to Florida.
All right. That sounds like the trip I'm used to.
Yeah. I don't know. My main word is calculus.
Yeah,
This class is not really worried.
Yeah. yeah. Calculus, you'll have your test.
Next week.
Yep, we'll test next week. I guess it's next week, Tuesday, we'll test.
So you gave us all the homework.
Yep.
So I know what to do and just
Yep.
be ready.
Crank through it.
Oh gosh, not being in class with.
Hey, get to go to Florida.
Yeah.
That might be worth taking a low grade on a test, right?
I think it is.
Yeah, I think so too.
Be good.
Yeah. You want to sit out there?
Do you have staplers?
I do back here. How you feel, bud?
Yeah.
Your calf just tiny.
Pretty small. It's not
And I've broken my leg. I got my calf. I took it out the food. It's like it's about a third of the size of the other
Can I still calculate this?
Sure.
$60. 60 plus
Okay, so one of the problems is wrong. Just gonna change it here for you.
Did she do better in this class? Probably like. Are you ready to take the test?